Area. The fundamental theorem of calculus shows the connection between the two basic processes, differentiation and integration. One part of the fundamental theorem is that the integral from a to b of f of x dx is equal to f of b minus f of a, where capital F of x is the antiderivative of f of x. It is used to find the area under a curve between a and b, as indicated in the diagram over here. If the area trapped is above the x-axis, the integral will give a positive answer. If it is below, it will give a negative answer. That's not complicated to explain, and I'm sure you've seen this before. But if we have an area below, when we take the fundamental strip, the y is negative, and up here when we take the strip, I think it's called elementary rather than fundamental, the y would be positive, and that's why this one ends up being a positive signed area and this one a negative signed area. But of course, area itself must be positive, so the negative is just indicating that we're below the x-axis. Extreme care must be taken if the area is part above and part below, as the areas will cancel out. And if this were symmetric up here, when we integrated, if we integrated from here to here, we would end up with 0, even though we can clearly see there is area. So what we'd need to do is take a point in the middle C, work out this area, and then work out this area up here, and then add them together, ignoring any negative signs. So if this is the case, deal with the parts above and below separately, as I just talked about. You don't need to do that if you're on the class pad, because what you can do is you can do the modulus of your function, and the effect of that would be that if we drew the function, anything above would stay above, and then anything below would reflect upwards, and then all of your area is above. And this has applications in methods as well as specialist.